You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. So now let's see how to implement the InterVlan configuration. The first IP is 10.100 and the second switches VLAN 10 IP is 10.150. So if you ping from 10.100 to 10.150 as per the VLAN configuration, it will work, right? So it's pinging. You can get the reply. But you can't ping to the 20.150, 192.168, 20.150, which is in a different VLAN or different network. So when you ping from 10.100 to 20.150, you can't get the out. Okay, it will be request timeout. Okay. Without waiting, if you want to stop this pinging, you can press Ctrl plus C, right? So as per same VLAN devices can ping, and if you want to ping from different VLAN or VLAN to VLAN communication, you need to use a layer 3 device, which is a router, right? So let's attach a router to one of the switches. Also, if you need serial ports, you can see only fast Ethernet ports are there in the router. So if you need serial, just turn off the router and add WIC2T module. Okay. And turn it on again. Go to config, you can see the serial ports are available, right? So we need to wait till it boots up and press OK. And now we can assign IP address via GUI, which means graphical user interface, or else we can do it by the command line interface. We need to connect the cable next. From router to switch, we need to select straight through cable because router is having the MAC address and switch is non-MAC device. So MAC to non-MAC, we need to use the straight through cable. So F01 port connected to the F01 of switch. Okay. It's not a must, but you must ensure from the switcher side you should have the default port. Okay. You shouldn't connect it to a VLAN spot. Okay. So when you connect the router to the switch, in the switch, it shouldn't be a VLAN spot. Okay. The port shouldn't belong to any VLAN. It can be in the default VLAN. And from the switch side, you need to make it as trunk. Okay. All the VLAN configurations are same. So I'm not going to repeat it. You can view the previous session so you will understand it better. In the router to switch, we need to make the switch virtual interfaces, which means we are configuring router on a switch. You can see like ROAS. So where we use only one physical interface and make the physical interface in active status by giving the no shutdown command, like interface FA01 no shutdown. You don't need to specify any IP address for this physical interface. Okay. Then what you do is you will create virtual interfaces by specifying, for example, interface FA0/0 means to create a virtual interface, you can specify interface FA0/0.10 or .20 likewise. So the decimal point is there to confirm that you are creating a virtual interface. Okay. So now we have created the physical interface into active status. We made it active by interface FA01 no shutdown command. Now we can verify the interface by show IP interface brief. There is no IPs assigned yet. Okay. Now we are in the config mode. Let's create the virtual interfaces. So interface FA0/1. Now since it's again the physical interface, okay, we are turning it on. Okay, interface FA0/1 no shutdown. We didn't assign any IP address to this one. Next, virtual interface. Interface FA0/1.10 encapsulation.1q10 IP address 192.168.10.1 255.255.255.0. And again for interface FA0/1.20, which means for VLAN 20 I am going to do this, so I am just using .20. You can use anything, but in the encapsulation.1q, the next number 20 must match the VLAN number. Okay, that is the VLAN tagging number. Then IP address has been specified. Okay, so these are the IP addresses which are going to be the gateway, default gateway for your end devices. For VLAN 20 end device, you will specify 192.168.20.1 as the default gateway. Okay. For VLAN 30, as you can see, you will use the 192.168.30.1 as the default gateway. Okay. And if you assign more spaces in between, sometimes it will throw an error. Okay. Don't add additional spaces like this. Sometimes it shows an error. Okay. So show IP interface brief. To verify the IP addresses. Okay. You can use show run command as well. Okay. So here you can see the interfaces and the IP addresses and the protocol and status of this. Okay. Protocol and status are up means the link is working fine. You can see the dot decimal point interfaces are logical, which are switch virtual interfaces. Okay. So here now see in the device we are adding the 10.1 as the default gateway. So 20.1 is going to be the default gateway for the VLAN 20 devices. So now all the default gateways are added, okay, for end devices. Now you need to make the switch F01 port as the trunk, okay, from the third switch, which is connecting the router. You need to make it as trunk by interface FA0/1 switch port mod trunk. That's all. By doing this, your each and every VLAN traffic can travel through that link on the router. Okay. So now what happens is, whenever you try to ping to the VLAN 20 from VLAN 10, it's going to travel through the router and reach the other VLAN. So now let's see the VLAN brief database, show VLAN brief, and you can see the port numbers and all. So F01 is in the default VLAN. Okay. So now we are making it as a trunk. After configuring as trunk, it won't show in the VLAN database. Okay. Let's check. Interface FA01, switch port mod trunk. Now exit and you can try the show VLAN brief again. So now if you see that the F01 port is not there in the VLAN database. Why? It has been turned into a trunk port. If you try show interface trunk, you can see that F01 is mentioned. And F0/23 is the other trunk port which is connecting to the switch. Another switch is there, second switch. Okay. So now if you save it by do WR on config mod, if you want to save, you can use the DO in front of the commands. If you have any show commands, you can type in config mod by typing DO space the command. Okay. And now we are reaching the router's interface and saving the configuration by copy run start. And now you can see again you type do space copy run start in config mod to save it. Okay. Or do space write. Okay. Do space show run I'm typing to check the show running configuration. So I can see the interfaces and the IP addresses, everything. Right. Make sure your decimal, which means your SVIs, virtual interfaces, which is having the encapsulation .1q number, that tag must match your VLAN number, right? But it is not a must to have the interface FA 0/0 dot and the number next to it. It doesn't have to match the VLAN number. You can use any number, okay? Which means the decimal number I'm saying. Now let's see the ping from VLAN to VLAN. From 10 dot, I'm trying to ping the 192.168.30.100. Okay, the ping should work, but initially some packets might drop due to the address resolution protocol. You can see request timeout came for the first packet, and the remaining packets are getting the reply from the 30 dot network. Okay, the address resolution protocol is due to the MAC address is unknown. Okay, because initially the switch doesn't know the MAC address of the attached PC, so it lost one of the packets. And now again it has noted the MAC address after the first ping. Again, if you try to ping the same IP address, now it won't have any loss. It will work fine. Okay, you can see all 4 packets are being pinged. Okay, you can go to the simulation and check how the packets are traveling through that. So edit filters and uncheck all others except the ARP and ICNP packets. Okay, when you try to ping, mainly we can focus on that. So go to command prompt and ping, minimize it, and by forwarding one by one or auto playing, you can view the packet flow. Okay, if you want to click the packet, and you can see what are the source address, what are the destination address, and the inbound PDU, and how the outbound PDU looks like. Inbound PDU is how the packet looks like when it reaches the switch. Outbound is how it looks like when it is leaving the switch. Okay. You can visit our website for the commands in the videos If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. Just forward it. Step by step you can forward and you can just simply understand it. Okay. Most probably as a basics, just try to understand what are the source and destination. Okay. You can compare and figure it out. Source means where the traffic is generated. Destination is where it is aimed at, where it is going. Okay. So here the traffic is 10 dot and it's reaching the destination 30 dot. So via the router, again it's reaching the other logical interface and trying to reach the 30 dot network. Okay. So now the traffic reaches 30 dot. So here from the source, the traffic reaches the destination. Doesn't mean the ping is successful. Okay. Because it needs to return to the source. Then only the ping is successful. Okay. So we need to again forward step by step and see until it reaches the source or not. Okay. Once after it reaches the source, which means the ping is successful. Okay. Now check the source and destination would be interchanged, which means the source would be 30 dot, destination would be 10 dot. Okay, you can see that. So it's reaching the source again. Okay. So you can see the arrow pointing correct icon. So the ping is successful. So this is how you can check the simulation. Okay. By clicking on the particular packet, you can verify what is the source, destination. And these are the OSI layers. From layer 1 to 7, it's been showing. Okay. There are two layers, which is OSI layer and TCP/IP layer, which we will learn in the questioning format. Okay. So now to save time, just don't get misdirected by learning all the theories and stuff. Okay. Initially, just start upon the practical labs. Then it will be easier for you to understand the concepts. So by using the router and creating the virtual interfaces, you can ping from one VLAN to another VLAN device as well. Okay. So this is called the InterVlan configuration. So as a summary, from VLAN to InterVlan, only the difference is you are changing by connecting a router and making the physical interface of the router into active status and then creating virtual interfaces on that particular link by using the encapsulation.1q command. Okay. Encapsulation command is used for 802.1q protocol, which is for the trunking encapsulation protocol. So because of the 802.1q, we are specifying as .1q. Okay. Then just create the trunk setup on the switch side. Okay. So here, as always, you create the VLANs earlier as you created. Again, make the port setups. Those are basics, right? When you do the VLAN itself, you have done this. You need to create VLANs, then port assignment, then trunk setup. In addition, for the InterVlan setup, you are just attaching the router, creating virtual interfaces on the router's link, and trunk setup on the switch side. For the physical interface of router, you don't need to give the IP address, just assign the active status by using the no shutdown command. And also the router's virtual interface IP addresses are going to be the default gateway for your end devices. Okay. By that virtual interface IP only, it's going to meet the other network. Okay. So network to network communication happen by. Okay. To remove an IP address, simply you can enter inside the router's interface, which means, let's say for example, if you want to remove the IP address, just enter interface FA 0/1, which means imagine you are going inside the interface. Now let's say if you want to remove in virtual one, go to interface FA 0/0.10 and type encapsulation.1q10 and give the no IP address command. Okay. So now I am just configuring it. Okay, let me configure it and then I can show you how to remove it. So interface FA 0/0.20 encapsulation.1q20. So all three interface IP addresses are given for virtual interfaces. Okay. Here remember it's interface FA 0/0, but for physical one I have attached interface FA 0/1. This is just to explore how it looks like when we wanted to remove an IP. Okay. So now we have configured. So show IP interface brief is showing the IP addresses in this router. Save it by WR, which means write command, or copy run start and enter. So now let's see the difference is there, right? So FA01 and FA0/0 has been done. So it's a misconfiguration. So we need to remove it. Go to config T, which means config mod. Enter the interface. Interface FA 0/0.10 space no IP address command and no encapsulation command. That's it. Encapsulation.1q10. Okay. No IP address command and no encapsulation.1q command. Okay. So again you can retype the interface. Interface FA 0/0.20 or 30. Again no encapsulation.1q command and no IP address command. Okay. By doing this you can remove the IP addresses. Okay. So trunking encapsulation protocol standards are there. 802.1q is open standard and another one ISL is the CISCO standard. Okay. So generally we are using 802.1q instead of the So now if you try show IP interface brief, you can see the IPs are removed. If you want to remove even the interface, which means FA0/0.10, simply go to config mode and type no interface FA0/0.10. Okay. These are just to show you how to remove the IP address and all. Okay. So you can make sure if you miss anything, you can confirm that how it should be troubleshooted. So that it's open standard. One is 802.1q and ISL is the CISCO proprietary. So we are using the 802.1q by mentioning encapsulation.1q. Okay. Interface FA0/1 and I am typing no shutdown, which means I am making the physical interface in active mode. And again interface FA0/1.10, okay, which is going to be my virtual interface. IP address I am assigning it 10.1. Okay. So here I need to specify encapsulation.1q before I mention the IP address. Okay. So this is what the error which points when you mention the IP address directly. Okay. You can see configuring IP for the virtual interface is only allowed if that sub interface is already configured as part of the IEEE 802.1q. So this is the reason you need to make the encapsulation.1q command. Okay. Then you can assign the IP. So first to create the virtual, you need to type interface FA0/1.20 and then encapsulation. After encapsulation command, you can assign the IP address. You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics.